So here we are looking at special triangles. We want to find, the goal here is to find the trig ratios of some special acute angles. So let's start with this one. This is a unit square. A unit square, it simply means is a square whereby every place is 1. So this is 1 unit, 1 unit. It could be in centimeter and all of that measurement. So here we can see that each of these is what is 90 degrees, right? Because we have this is like a square, right? So each of this angle will be 90 degree. Now, if we draw a perpendicular bisector here, I can draw just a line to bisect this 90 degree. So you can see that here will be 45 and here will also be 45. And we can use Pythagoras theorem. By Pythagoras theorem, we can get that what this side is going to be just what square root of what? Square root of 2. Why is it square root of 2? Because this is a right angle. So let's say we consider here to be A, B, C, D, right? So if you take any of this, you're going to use Pythagoras theorem to get this length, because this length is 1, this is 1, so here's going to be root 2. So let's bring that out. So let me just bring any of it out, like, no, let's use this one here. So here is 45, here is 90, and here is also 45, right? Degrees. So here is 1, and this is the root 2. So we're trying to use this one, BCD, right? So it's also the same. BCD and ABC is also the same. So you can use anyone. So as you can see here, we can have what is sine 45. Now, if you are considering any of the 45, so it's your choice because all the angles are 45. So let's maintain this 45. Let's maintain the 45 at C. So let's say we are using this 45 degree. So if you're using this 45 degree, remember sine is going to be what? Is y over what? Over r. And what is our y? This is going to be our y here. Y is going to be the opposite. Right, so this is going to be y. So this is y. This is going to be x. And this is going to be r, right? So y over r is simply going to be 1 over root 2. And this from here, we can also get what is cosec 45 degrees, which is going to be root of 2. Then cosine 45 k, which is adjacent, so it is x over r. X is also 1, root 2. So this means that what? Sec 45 is also root 2. And then we go for tan 45. For tan 45, tan is what? Y over x, which is simply going to be 1 over 1, right? And what is 1 over 1 is equals to 1. This also means that cotan 45 degree is equals to 1 as well. So these are just the trigonometry ratios for the 45 degrees, right? Now, let's go straight for the 60 degree. Now we're going to use equilateral triangle. But this equilateral triangle simply means all the sides are equal. But here we're going to use of size 2. Let's assume that everywhere the length is 2 units, right? Now, since this is an equilateral triangle, it means that there is going to be 60, here is going to be 60 degree, all the angles will be 60 degrees. And then we can draw a perpendicular bisector just to cut. So if you draw a perpendicular bisector to cut this, it means here will be 1, here will also be what? 1. And you have a right angle here. So if you bisect this perpendicularly, what do we have? Here will be 30 degrees. Here will be what? 30 degrees. So just like we did before, you can take any of the sides. So this is A, B. Let's call this D, and this call is C. So we just need to take one part of it. You can take A, B, C, A, B, D, or we can take A, D, C. But one thing we need to find is the what? Is the length of the perpendicular bisector, AD, right? And we can also use Pythagoras theorem, because if this is the right angle, let's call these, let's say this is the right angle, so we can see that 2 squared is going to be what? 1 squared plus what? X squared. Let's call this part X squared. Let's call it just X, or any letter will do. So you will see that this is nothing but the square root of what? The square root of 3. Because you will have 4 squared minus 1 squared. Let me use a black. So this is going to be square root of 3. Just by using Pythagoras theorem. Don't forget that this length here is 1 unit. The length here is what? Is 2 units. So with this, we can, so let's just bring it out. So let's bring just one out on side. So now I'm taking A, D, and C. Here is 90 degree. Here is 30. And here is what? 60 degree. So this is 2. This is 1. And this is the one we calculated, root of 3, using Pythagoras theorem. So what it means is that we can find, for example, if I need sine 30 degree, if you need sine 30 now, you have to consider this angle. So what is sine 30? Is going to be opposites, which this is going to be our opposite in that case. So this is going to be our y. So this will be 1 over, what will be our hypotenuse? Look at the right angle. The right angle is facing 2. So hypotenuse is 2, right? And this also means that you can have what? Cosec 30 degree is just 2 over 1, which is 2. Then we go for cosine 30. Cosine 30, we're still using this angle. Remember, cosine is adjacent. In that case, this will be our adjacent here. And our hypotenuse will still remain this one. Yes. So here, let me put it here. This is our opposites. So this will be root 3 over 2. And this means that sec 30 is what? Is 2 over root of 3. We can rationalize it as well. Then we go for which one again? 30 degrees is opposites over adjacent. So it's going to be 1 over root of 3. And that means that what? Cotan of 30 degrees is just root 3 over 1, which is root of 3. All right. Then let's turn now to something else, which is another angle. Let's concentrate now on angle what? Angle 60. So it means we're done with this. So if we want to concentrate on angle 60, then we need to change something. So this is our focus, 60. In this case now, here will become the opposites, because the 60 is facing this. Then right angle, you can see the hypotenuse will still remain. But now what will change is that this place becomes our adjacent. Because remember, adjacent is the distance between your acute angle and the what? The right angle. So the 90 degree. Okay. So from here, we can go with sine of what? 60. Sine 60 is still going to be y over r. In other words, it's opposite over hypotenuse. What is our opposite? Is this place now, which is going to be root 3. Then the r has not changed, which is still the hypotenuse, which is 2. And this means that we can get cosec 60 to be 2 over root of 3. Then cosine 60 degree is just going to be x over r, which is adjacent over hypotenuse. And if this is 60, the adjacent is this one, which is 1 over hypotenuse has not changed, which is where the right angle is facing. So it's 1 over 2. And this means that sec 60 degree is what? Is 2 over 1, which is 2. All right. So what else here is tan 60? Tan 60 is what? Is opposite, so which is like y over x. So it's going to be opposite. Our opposite now is root 3. So you have root 3 over adjacent 1. And that means that cotan 60 is just going to be 1 over root of 3. So in you looking for these trigonometric ratios, so we can use this is just the summary. We can use this triangle when we are dealing with 45. So it's just 1 unit, then the hypotenuse is root 2. Or we can use this one here to get. So once we remember these two diagrams, we can find all the trigonometric ratios. So for 90, we will talk about it much later in another section. So, but here we have like a faster trick or a trick we can use. So we can use our fingers, as you can see. Here we call it what? 0 degree. You start labeling your fingers from 0, 30, 45, 60, and 90. So if you want to find, for example, like you want to deal with sine 0 degree. So all we need to do is you count the number below. You count the number below the finger. And then what do? You take the roots. All right, so for example, if we want to find sine 0 using the fingers, so all we need to do is we calculate how many fingers do we have to the right. In this case, we don't have any fingers there, so it's just 0. So we divide root of 0, then we divide by what? By 2, and this is just going to be 0 over 2, which is 0. So if you want to find sine 30, this is just a demonstration. Sine 30 is going to see, you are coming this way. How many fingers do we have after this angle? It's only 1, right? So we're going to take root of 1, we divide by 2, and this is just going to be 1 over 2. So if we want to find sine 45, right, you can see sine 45, what do we do? Sine 45, this is 45, right? So we've count how many fingers do we have? We have this one, we have 1 and 2. So remember, we're coming this way, 1 and 2. So it means we have 2 fingers. So you take the square root of that 2, then you divide by 2. So this is sine 45. Remember, sine 45 is 1 over root 2. But if you rationalize 1 over root 2, you get root 2 over 2. Okay? So this is how we go about it. Then let's just take that of cosine, for example. For example, now if we're looking for cosine 0, for cosine 0, remember, where is 0? This is 0, right? So in that case, you have to go this way. So how many fingers do we have to the left now? We have 1, 2, 3, 4. So you take the square root of 4, you divide by 2. This is nothing but square root of 4 is what? Is 2. 2 divided by 2. This is 1, right? Now let's just take one more for here. Let's go to cosine of what? 60 degree. If we want cosine of 60 degree, I just need to come here. Take your fingers. This is cosine. This is 60 degree. But remember, for cosine, we go left. So how many fingers do we have to the left? We have only 1. So it means it will be the square root of 1 divided by 2, which is just 1 over 2. So this is how we can find all of these ratios. Let's add one more. Let's add cosine 30, right? For cosine 30, this is 30 degree. It means we have to go this way. So you will see that cosine 30 is nothing but what? Let me do it here. Cosine 30 degree is just, how many fingers do we have to the left? 1, 2, 3. So it's going to be root of 3. We're still dividing by 2. All right, so these are just some fast tricks to be able to get these trig ratios. That is, instead of using these diagrams that we did earlier. All right. So another one is this one here. We can also use this. Here you have your theta, which is theta 0, 30, 45, 60, and 90. Then you can write your sine theta. It's just the root of what? You're starting from 0, 1, 2, 3, 4. But everything you are dividing it by 2. So it means if you're looking for sine 0 degree or 0, it's just, since you are dealing with 0, it will be square root of 0 divided by 2, which is still 0. For sine of 30, you are in this column. So you will take 1. So it will be root of 1 divided by 2. For sine of 60, we are in this column. So 60 corresponds to 3. So it will be square root of 3 divided by 2. And if you need even 90, it works for 90. Sine 90 corresponds to what? 4. So it is square root of 4, which is 2 divided by 2. So sine 90 will be 1. Okay. And so for cosine theta, you just reverse the order. Instead of starting from 0 to 4, here we are starting from 0 to 4. Here you start from 4 to where? From 4 to 0. And then it's easy to see that what is tan theta? Tan theta is just to be sine theta over cosine theta. So you have square root of from 0 to 4 divided by from 4 to where? From 4 to 0. Because the two will cancel in the denominator, right? So for example, if you need tan, let's say tan 30, tan 30 we're here. So it means you have square root of 1 divided by square root of what? Root 3. So you have 1 over root of 3. If you need tan 45, it's just square root of 2 divided by square root of 2, which is going to give us 1. All right. So let's just answer some few questions here. So here, what do we have? We see that we want to find the exact value of the expression. So this is it. We want to find sec 45. Pi over 4 is the same thing as sec 45. But we know what cosine, yes, cos 45 is. So this is just going to be root of what? Root of 2, because we know that what? We know that cosine pi over 4, which is, it's just going to be 1 over what? Root 2, right? So it means sec will be just root 2. So this times, this is cosine pi over 6. What is cosine pi over 6? Cosine pi over 6 is nothing but cosine of 30. But cosine of 30 is root 3 over what? Root 3 over 2. Okay. Then minus, this is tan 60. Tan 60 is what? Is root of 3 multiplied by, now here we have cotan of what? Cotan of 60, right? Which is just going to be the reciprocal of this. So this is 1 over root of 3. And clearly this is just going to be root 6 over 2 minus what? Minus 1. All right. You can leave it this way or you can simplify it more. It's All right, so here, this is just going to be sine 45 degree all square is the same thing, plus cosine 60 degree all what? All square. But what is sine 45? Again, is 1 over root 2, right? All square plus cosine 60 is half, 1 over 2. So you have 1 over 2 all square. And here will give us 1 over 2 plus what? Plus 1 over 4. And this should be 1. You can multiply this by 2 over 2 so that you will have 3 over 4. Okay. Then this is, here you have to finish what is inside. So sine, so here we have sine what? Sine pi over 3. What is pi over 3? Is 60, right? So sine 60 should give us root 3 over 2 multiplied by cosine pi over 4, which is like what? Cosine 45. Cosine 45, we know it's 1 over root of 2. Minus sine 45 also is the same story, 1 over root of 2. Then we are multiplying by what? Cosine of pi over 3, which is the cosine of 60, right? But what is cosine of 60? Cosine of 60 is 1 over 2. So all of this we're going to square. And what do we have here? This is just going to be root 3, right? Minus 1. Am I correct? Over what? Oh, not 4. Over 2. 2 root 2. Okay. All square. So here, what can we do? We can just square both sides. If you square this, if you square the denominator, you should have 1 over 4 times 2 outside. Because 2 squared is 4, root of 2 squared is going to be 2. And then you're going to have just this one, all squared. And what else can we get from here? We just need to expand here. This will be 1 over 8 into, this we can use, this will become 3, right? Minus 2 root 3. Yes, then plus 1. Okay. And this is just going to be 1 over 8. This will be 4 minus what? 2 root of 3. And we can take 2 outside so that you have 2. And then you have 2 minus what? Roots of 3 over 8. Correct. Okay. I hope everything is correct here. All right, so let's just look at these again. This is sine 60. Sine 60 is root 3 over 2, cosine 1 over 2. And this also 1 over root 2. But we have cosine of 60 is half. So here you have root 3 minus 1 over 2 root 2. Then if you square it, you have 1 over 4. And then you have a 2. Then here you can expand this. Yeah, so I think it's fine. All right. Now for this one, D, what is D? D, we're dealing with what? We're dealing with cosec, right? So cosec, we know, is just going to be what? It's just going to be the reciprocal of what? Of sine. What is sine 45? Sine 45 is 1 over root 2. So this is just going to be root of 2. Minus, this is sec 60. Sec 60 is the reciprocal of cosine of what? 60. But we know that cosine of 60 is half. So sec 60 is going to be 2, right? Then cosine 30, we know what is cosine 30. Cosine 30 is nothing but root 3 over what? Over 2, right? So here we just need to simplify. So this is going to be 2 root 2 minus root of 3. And I think this is the best we can get, because here 2 will cancel 2. Okay, so this is how to find the trigonometric ratios when you are dealing with 30-degree, 45-degree, yeah, on 60 degrees. These are all acute angles. So in our next video, we'll be looking at the application questions where we'll have to solve a triangle looking for the missing side. Thank you for watching. If you enjoyed this video, you can give it a like and share with your friends. And don't forget to subscribe if you are new to this channel. Thank you for watching.